In late 2025, every telescope aimed at Mars started to show something faintly wrong. Not dramatic, not explosive, just wrong. The planet's upper atmosphere, normally calm this time of year, began to shimmer in wavelengths that didn't belong there. Astronomers traced the anomaly backward and found a single coincidence: the passing of the interstellar object known as 3I, Atlas. It wasn't supposed to affect anything. It wasn't even supposed to notice Mars. Yet for reasons no model predicted, Mars has changed. Stay with me until the end as we uncover, step by step, what this visitor may have done and why silence from the agencies studying it might be louder than any transmission. If you're watching this in real time, tap like, subscribe, and tell me where you're listening from and what time it is on your clock. By early October 2025, the object known as 3I Atlas was already rewriting what astronomers thought they understood about interstellar visitors. Unlike Oumuamua or Borisov, this one wasn't passing quietly through the void. It was interacting, stirring, and leaving measurable fingerprints on its way in. Its trajectory had been projected months earlier. A sweeping hyperbolic curve dipping through the inner solar system, crossing just above Mars's orbital plane before vanishing behind the Sunday. But what no one expected was how close that path would take it to the red planet. From observatories on Earth, the geometry looked harmless. The official minimum approach distance, roughly 9.8 million kilometers, sounded vast enough to be meaningless. Space is big. Comets glide past planets all the time, but distance alone doesn't tell the full story. At 60 kilometers per second, a body of ice, metal, and volatile compounds ploughing through the solar wind carries with it a long tail of plasma and dust stretching millions of kilometers. That tail, thin as mist but electrically alive, can reach across emptiness and touch a world without ever colliding with it. And that's what Mars was about to experience. As Atlas neared the inner solar system, the Solar and Heliospheric Observatory, SOHO, recorded changes in the density of the solar wind around it, subtle ripples moving outward, like the wake of a ship crossing calm water. NASA's Parker Solar Probe, orbiting far closer to the Sun, registered the same pattern at a slightly delayed interval, suggesting the disturbance had propagated across the heliosphere. By triangulation, those waves pointed toward the corridor between Atlas and Mars. It wasn't direct evidence of interaction, but it was enough to make mission controllers at ESA's Mars Express and NASA's MAVEN probe begin continuous monitoring. On October 17th, MAVEN's magnetometer picked up its first anomaly, a short, rhythmic flutter background noise at first, then structured oscillation. For 28 seconds, the data fluctuated in amplitude exactly once per second, like the slow heartbeat of something enormous drifting nearby. Engineers double-checked their instruments, assuming calibration error, but when Mars Express recorded the same pattern half an orbit later, the coincidence became data. Meanwhile, ground-based tracking stations were refining Atlas's orbit. It wasn't behaving perfectly. Tiny deviations kept appearing, consistent with uneven outgassing from its surface. Each correction nudged its predicted periapsis closer to Mars by small but noticeable amounts. By mid-October, it was clear that Atlas's plasma tail ionized dust streaming backward from the Sun could overlap Mars's magnetosphere for several hours. That overlap, invisible to the eye, meant charged particles from another star system would literally brush the Martian sky. Astronomers argued over what that would mean. Most said, nothing measurable. The planet's atmosphere is too thin, its magnetic field too weak, its distance too great. But a minority pointed to the comet-siding spring encounter of 2014, when a normal solar system comet had passed just 140,000 kilometers from Mars. That event had produced auroras visible from orbit, and temporarily altered the planet's ionosphere. If a small comet could do that, what would an interstellar one do from 10 million kilometers away, especially one emitting a dense stream of exotic particles moving faster than any we'd ever studied? By October 19th, the alignment was exact. From Earth's perspective, Atlas and Mars appeared in the same quadrant of the sky, both sinking into twilight near the Sunday. Radio contact with Mars orbiters crackled with interference, later dismissed as normal solar static, but within those recordings are faint, repeating bands the same frequency oscillations seen by MAVEN just days earlier. Something was passing between them, carrying an electrical rhythm across space. That night, for the first and only time before conjunction, the James Webb Space Telescope caught Atlas in mid-approach. Spectroscopy showed ionized nickel vapor streaming outward in two plumes, oriented directly toward Mars's orbital path. A day later, the readings vanished into solar glare. No one has seen the comet clearly since. When mission logs were reviewed weeks later, scientists realized that the timing of those plumes coincided precisely with Mars's magnetic flutter. Two data streams from two worlds, synchronized across tens of millions of kilometers. Coincidence, perhaps, but from that moment, the question changed. It wasn't whether 3I Atlas would hit Mars. It was whether Mars had already begun to feel its presence long before anyone was watching closely enough to notice. It started as a whisper in the data. On October 21st, 2025, the same week 3I Atlas slipped behind the Sun, NASA's MAVEN orbiter detected a faint surge in ultraviolet emissions above the Martian poles. At first, mission engineers assumed it was a calibration spike, the kind of random noise every long-running spacecraft produces after years in radiation. But this wasn't noise. The readings were consistent across multiple instruments, recorded at the same time from different orbital positions. The signal was real. When the raw telemetry was translated into visual spectra, it looked almost beautiful. Thin ribbons of red light cascading along magnetic field lines, faint but unmistakable aurora-like glows dancing over a planet that no longer has a strong magnetic field. Scientists have seen Martian auroras before, but always in response to solar activity. This time, the Sun was quiet. No flares, no coronal mass ejections, no reason for the planet's sky to ignite. The pattern of excitation showed a peculiar symmetry. Oxygen atoms at 130, 4 nanometers, carbon dioxide ions at 289.9, both spiking together, pulsing every few seconds as if driven by an external rhythm. To anyone glancing at the graph, it looked like a heartbeat, and when compared to solar wind measurements taken by Parker Solar Probe, the rhythm didn't match the normal solar flux at all. It matched the rotation period of 3I Atlas 14 hours, 2 minutes, 17 seconds. No one inside NASA would call that a connection out loud, but behind the scenes, data analysts started calling the anomaly the red static. It wasn't just a name. When MAVEN's radio antenna pointed toward the planet's night side, static noise filled the band, a soft hiss punctuated by rising clicks. The clicks repeated with mathematical precision, 0.071 seconds apart every single time. That repetition made it through every filter designed to strip out interference. It wasn't random, it was structured. Ground stations in Madrid and Canberra confirmed the same noise bleeding through their telemetry during downlinks from Mars orbiters. Each time, it appeared when Mars rotated into the same spatial quadrant that 3I Atlas had just crossed days earlier. When the planet turned away, the signal disappeared. Repeatable, traceable, and completely unexplainable. ESA's Trace Gas Orbiter tried to capture the phenomenon directly. Its instruments showed elevated levels of charged argon and oxygen, both indicators of ionized plasma sweeping through the upper atmosphere. If this were a normal solar event, those particles would descend gradually. Instead, they came in waves. Each wave carried higher energy than the last, peaking at 11 electron volts, enough to disrupt shortwave communications between orbiters and rovers. That's when Perseverance briefly lost contact for 6 minutes, and engineers blamed dust interference that wasn't there. Meanwhile, images from the HOPE probe showed a strange faint glow along Mars's horizon. To the untrained eye, it looked like dusk bleeding into night, but filtered through spectrometers, the glow emitted a narrow band of deep crimson light from excited oxygen atoms, recombining after ionization. It formed a ring around the planet like an electric halo, pulsing faintly against the void. For almost 20 minutes, Mars shimmered red, then faded back to black. By the next morning, the static vanished. No lingering radiation, no residual magnetic storms. Only the data remained, thousands of gigabytes of logs showing a planet that for less than half an hour had been bathed in invisible energy from an unknown source. When scientists later overlaid the timeline of the red static with 3I Atlas's final visible trajectory, the alignment was unnerving. The pulses in Mars's upper atmosphere began just as Atlas crossed the heliospheric current sheet, the Sun's vast electrical boundary, and ended when the comet disappeared completely from view, almost as if whatever charge it carried had discharged into the solar system, and found Mars waiting in its path. Most researchers settled on a cautious explanation. Charged particles from Atlas's ion tail likely rode the solar wind, temporarily coupling with Mars's magnetosphere to create short-lived auroras. But others noticed something harder to explain: the mathematical spacing of those pulses, precise enough to resemble a transmission rather than turbulence. If it was natural, it was the most organized random signal ever recorded in Martian space. If it wasn't, it might mean Mars had just listened to something that wasn't supposed to speak. Dust is supposed to be ordinary. On Mars, it's the planet's signature, the fine oxidized powder that paints the sky red and covers every lander we've ever sent there. But the dust that appeared in late October 2025 wasn't Martian at all. It shimmered, not in sunlight, but in the dark. The first detection came from the Emirati Hope orbiter, which scans Mars's atmosphere using its Emirates Mars ultraviolet spectrometer. During a standard limb scan, the instrument picked up a high-altitude layer of particulate matter, drifting roughly 120 kilometers above the surface. At that altitude, natural dust shouldn't exist. It should fall or be blown away by the solar wind. Yet there it was suspended, faintly luminescent and rich in elements Mars doesn't make. The spectral fingerprint startled everyone. Instead of the usual iron oxides that give the planet its rust-red hue, the particles reflected signatures of nickel, argon, and traces of manganese metals never before recorded in the Martian atmosphere. At first, mission scientists suspected contamination from the sensor. They recalibrated, ran dark tests, and repeated the scans. The glow remained, and its pattern was moving eastward the same direction 3i Atlas had been travelling before it vanished behind the Sunday. For 3 consecutive orbits, Hope's instruments logged the particles pulsing faintly at ultraviolet wavelengths. Each pulse coincided with slight magnetic fluctuations detected by the MAVEN probe orbiting thousands of kilometers away. 2 independent spacecraft, separated by half a planet, were sensing the same phenomenon. The data converged on one impossible conclusion. Mars was being brushed by something extraterrestrial, a microscopic rain of matter arriving from beyond the solar system. ESA's trace gas orbiter offered the next clue. While conducting spectroscopy passes over the northern hemisphere, it recorded scattering angles that defied the physics of Martian dust. The grains were unusually reflective, and polarized light in the opposite direction expected for silicate particles. The only known analogues for such behavior are interplanetary dust grains charged with plasma, like those seen around active comets. In other words, these weren't native particles lofted by a storm. They were imported particles riding magnetic fields from somewhere else. That somewhere pointed toward the path of 3i Atlas. Weeks earlier, while still observable, the interstellar object had been shedding fine metallic dust from its coma. The James Webb Space Telescope catalogued those emissions. Minute flecks of nickel-carbon compounds accelerated outward by solar radiation. Most of that material should have dispersed into the void, yet somehow, a fraction had intersected Mars's orbit perfectly. It wasn't just timing, it was geometry. The planet's magnetotail, faint but present, had swept through the very corridor Atlas's dust was travelling in. It was like a cosmic net catching fragments from another star. On October 26th, MAVEN's mass spectrometer confirmed the impossible. It recorded a surge in heavy ion counts particles with atomic weights far beyond anything Mars naturally expels. For 7 minutes, the readings spiked to levels normally associated with comet encounters. Then, silence. Whatever passed through the instrument's path had come and gone. From the surface, Perseverance's sky camera captured a faint, diffuse haze, unlike any dust storm in its logs. It glowed faintly along the horizon, even on the night side. Mission Control dismissed it as exposure artifact, but post-processing revealed something real. A film of highly reflective grains clinging to the rover's mastcam lens. Their chemical analysis minute traces, collected on filters, matched nickel-rich material never found in Jezero crater. And one sample contained a stable isotope ratio, inconsistent with anything formed in our solar system. Scientists tried to explain it. Perhaps interplanetary meteoroid streams had coincidentally crossed Mars at the same time. Perhaps solar wind had charged normal dust to a degree that made it luminescent. But no natural model fit both the timing and the composition. Nickel and argon in those ratios should not exist together in any known Martian environment, and certainly not floating 120 kilometers above the ground, glowing softly in ultraviolet. By November 1st, the layer had dissipated. MAVEN's readings returned to baseline. The glow faded, But days later, InSight's aging seismometer recorded a faint static tremor, as if something microscopic but charged had been dragged through the atmosphere and down into the soil. Researchers now call it the transient dust anomaly. To the public, it's a footnote. One more unexplained blip in a decade full of them. But in quiet internal memos, one line stands out. The composition of the suspended dust matches the preconjunction tail material of 3I Atlas within measurement error. If that's true, then for the first time in history, Mars was literally touched by another star system coated, however briefly, in the dust of a traveller that didn't belong here. On Mars, temperature is supposed to be predictable. The planet's thin atmosphere and long, slow days produce clear thermal rhythms. Heat rises sharply at noon, plummets by dusk, and stabilizes near -70 degrees Celsius overnight. For decades, data from orbiters and landers have followed that pattern with mathematical precision. Then came the morning of October 31st, 2025. In the pre-dawn hours, one of the few surviving sensors from NASA's retired InSight lander began transmitting again. It wasn't expected to. The seismometer platform, silent for months, had powered up automatically after a voltage surge passed through the local grid. A grid that hadn't produced that kind of power since the mission officially ended. When engineers at the Jet Propulsion Laboratory reviewed the logs, they found something more intriguing than the reboot itself. A temperature spike. The reading climbed by 1.7 degrees Celsius over just 16 minutes, centered around local dawn at Elysium Planitia. That might sound small, but on a planet where changes usually occur over hours, it was enormous, the thermal equivalent of a lightning strike. Worse, it wasn't localized. Orbital infrared maps from the Trace Gas Orbiter showed a faint band of warmth stretching hundreds of kilometers, a diagonal path that crossed directly beneath the recent trajectory of 3I Atlas. The anomaly triggered an immediate audit. Solar input was the first suspect. If the sun had flared or emitted a burst of energetic particles, that could easily explain the warming, but the Solar Dynamics Observatory on Earth and the Parker Solar Probe both recorded nothing. No flares, no coronal mass ejections, not even a blip in X-ray flux. The sun was calm, so attention turned to the planet itself. Could geothermal vents have released heat from below the crust? Unlikely. InSight's entire mission had been dedicated to finding such activity, and its results showed Mars's interior was almost geologically dead. No volcanic tremors, no magmatic upwellings. The heat had to come from above. But from what? When scientists compared the timestamp of the spike with magnetic data from MAVEN, another pattern appeared. At the exact same moment, the spacecraft recorded a pulse in atmospheric ionization over the equator, a dense cluster of charged particles that lasted just over 20 minutes before dispersing. The pulse originated from the direction of the sun, but the trajectory was slightly offset, almost 10 degrees north of solar alignment, exactly where Atlas's tail would have intersected Mars's orbital position that day. At first, this seemed like coincidence, but as analysts layered the data, they found a direct correlation between regions of temporary atmospheric ionization and the areas where infrared imaging showed surface heating. Something high above Mars had briefly energized the upper atmosphere, and that energy had propagated downward as thermal radiation. No solar source, no volcanic source, only an invisible trigger. The leading hypothesis, quietly circulated within NASA's internal reports, was plasma entrainment. According to this model, the ionized dust streaming from 3I Atlas could have coupled with the solar wind to form a moving electromagnetic pocket. As that pocket swept past Mars, it may have induced currents within the planet's thin atmosphere, like an aurora that traded light for heat. Those induced currents could have temporarily warmed the air and surface before dissipating into space. It was elegant, testable, and terrifyingly new. If confirmed, it would mean that an object millions of kilometers away had momentarily influenced the climate of another planet, without any direct contact. A kind of remote interaction on a planetary scale. Nothing like it had ever been recorded. To test the idea, scientists reanalyzed older data from the comet Siding Spring encounter of 2014. That comet had passed far closer to Mars than Atlas, yet the observed temperature change back then had been only 0.1 degrees Celsius, barely measurable. Whatever happened in 2025 was an order of magnitude stronger. The mystery deepened when ground-based instruments in Chile and Japan picked up infrared flashes in the same wavelength band that Mars emitted during the spike. The flashes appeared on the night side of Earth, too faint to be seen by eye but visible to sensitive telescopes. It was as if Mars had blinked, not reflecting sunlight, but radiating its own. After 2 hours, everything returned to normal. The InSight sensor cooled, the orbital data stabilized, and communications resumed without explanation. But when the readings were compared against Atlas's projected path, the alignment was again uncanny. The comet's plasma tail would have brushed Mars's magnetotail within that exact time frame. A single sweep across space, invisible but potent. No official statement was issued. The temperature anomaly never appeared in public mission updates, only in archived telemetry tables. But within scientific circles, one quiet phrase began to circulate: thermal handshake. It described the brief exchange between two worlds that never touched, an unseen current of heat bridging tens of millions of kilometers. If that's what happened, then 3I Atlas didn't just pass Mars. For a few fleeting minutes it warmed it, and perhaps left a reminder that even in the vacuum between worlds, energy finds a way to speak. Every deep space communication begins with silence. Before a signal is sent, antennas wait vast dishes pointed toward emptiness, listening for noise that shouldn't be there. On November 2nd, 2025, that silence answered back. At 3:14 UTC, the Goldstone Deep Space Communications Complex in California was conducting a routine radar calibration. The team transmitted a test pulse toward Mars, a standard procedure used to synchronize signals between the Mars Reconnaissance Orbiter and the Trace Gas Orbiter. The pulse was unremarkable, a 10-megawatt burst of radio energy sweeping across the X-band, aimed directly at the planet's southern hemisphere. 22 minutes later, the expected reflection arrived, clean and consistent with the orbital positions of the two spacecraft. Then came another one, an echo faint, delayed by exactly 11.47 seconds, and returning from a completely empty region of space. At first, operators thought it was a bounce, a stray reflection from the Earth's ionosphere, or a side lobe from another antenna, but the frequency of the returning pulse was shifted subtly, but unmistakably by 8.9 Hz, a Doppler deviation impossible to produce by random terrestrial interference. The echo had travelled hundreds of millions of kilometres, reflected off something metallic moving relative to both Earth and Mars, something no catalogue recognised. They called it a phantom echo not because it was ghostly, but because it lacked an origin. No known spacecraft, asteroid or debris field occupied that corridor. The reflection came from roughly 2.3 million kilometres behind Mars, in the direction opposite the Sun, exactly where the tail of 3I Atlas would have extended in early November. It wasn't proof of interaction, but it was too close to coincidence to dismiss. Goldstone's engineers ran diagnostics for hours. Could a piece of old hardware, maybe a derelict probe from the 1,970 seconds, have drifted into position? Cross-checks with the Jet Propulsion Laboratory's small body database returned nothing. Every object large enough to reflect radar was accounted for. Whatever had answered Goldstone's call had done so without existing in any record. The following day, NASA requested confirmation from Canberra Deep Space Network in Australia. They repeated the same pulse sequence, aimed at a slightly different coordinate, this time offset to compensate for orbital drift. The primary echo from Mars came through as expected then. Faintly, the secondary one returned again. This time the delay was 11.32 seconds, suggesting the reflective source was moving. The Doppler shift had also increased to 10.1 Hz, as if the object or field was accelerating away. It was disappearing. Speculation began quietly within mission channels. Could the echo have bounced off charged particles, maybe a dense plasma sheet left behind by Atlas's trail? Ordinarily, plasma can't reflect radar so precisely. It scatters it. But if those particles were metallic nickel and carbon compounds, like the material JWST had observed venting from Atlas weeks earlier, then under the right magnetic conditions, they could behave like a temporary mirror, a radioactive veil hanging in space, conductive enough to send back a ghost image of Earth's voice. Maven's magnetometer offered an eerie footnote. At the same timestamp as the first phantom echo, the orbiter detected a short, localized spike in magnetic pressure, a bubble of ionization hovering just beyond Mars's bow shock. It lasted exactly 12 seconds. The coincidence between the echo's delay and the bubble's lifetime was impossible to ignore. It was as if the pulse had struck something real, something that briefly existed and then collapsed. When the signal data was transformed into audio, the way engineers sometimes do to study patterns, it produced a deep, hollow thrum, followed by a faint harmonic tone that rose and vanished. No message, no modulation, just a resonance. But buried in the waveform was one curious trait, a phase inversion at the midpoint, a flip of polarity that normally only occurs when a signal passes through a solid surface. In other words, the echo hadn't just bounced, it had entered something, then emerged, changed. NASA's public explanation, when the anomaly leaked weeks later, was concise. Likely radar interference due to plasma turbulence near Mars's orbital region. Yes, that was true enough to sound plausible, but too neat for those who had seen the raw data. Internal memos warned that the reflective geometry implied a coherent structure several kilometers across, far too organized for plasma turbulence. The event was never repeated. Goldstone tried the pulse sequence 5 more times in the following week, aiming at slightly different vectors. No phantom echoes returned. The empty corridor stayed empty, but when the recordings were cross-referenced with 3I Atlas's predicted coordinates during solar conjunction, a chilling realization surfaced. The object's plasma tail would have intersected that exact vector during those same hours. In other words, the radar beam might have brushed the remnant of an interstellar object. And for 11 seconds, the void had answered back, whether it was reflection, resonance, or something else entirely. No one can say. But every time Goldstone's antennas sweep past Mars now, the technicians pause for a moment before transmitting, because once, not long ago, the emptiness replied, and it replied in our frequency. Hydrogen is everywhere, and that's exactly why it hides so well. It's the most abundant element in the universe, invisible, weightless, and usually unnoticed unless something forces it to speak. On November 4th, 2025, it did. The MAVEN spacecraft was midway through its routine orbital sweep above the Martian poles when its mass spectrometer began recording a faint but measurable thickening of hydrogen atoms in the exosphere. Normally, Mars leaks hydrogen slowly, a byproduct of water molecules broken apart by sunlight. That loss is steady and predictable, a soft whisper of gas escaping into space. But this time the whisper became a shout. Within 90 minutes, the density of atomic hydrogen had increased by 21%, blanketing the planet in what one engineer described as a bubble of invisible steam. It wasn't a global dust storm, it wasn't solar heating. The sun, in fact, was still in a quiet phase, its radiation output steady. The anomaly had appeared too quickly and too uniformly, as if someone had drawn a veil around the planet all at once. Scientists on the ground initially thought MAVEN's instrument had malfunctioned. They rechecked calibration logs and compared them with data from the Trace Gas Orbiter and HOPE probe, 2 other spacecraft capable of detecting hydrogen indirectly through ultraviolet emissions. To everyone's surprise, both recorded the same event. Mars's upper atmosphere was glowing faintly at 121.6 nanometers, the Lyman alpha wavelength of atomic hydrogen. It wasn't just more hydrogen, it was excited hydrogen, charged by an energy source that didn't fit any local profile. The veil persisted for just over 6 hours. During that time, something curious happened. The escape rate of hydrogen from the planet dropped instead of rising. The gas was being trapped, not lost. That defied physics. Hydrogen, being light, should escape Mars's weak gravity easily once heated. Yet somehow, the planet's outer atmosphere had turned into a holding chamber. To understand why, researchers at the European Space Operations Centre began reconstructing Mars's magnetic field lines. MAVEN's magnetometer provided the clue. The field had temporarily reoriented, forming a loose arc that curved backward toward the Sun. The same geometry expected if the planet were immersed in a stream of charged particles flowing from the opposite direction. In other words, Mars wasn't just under solar wind. It was under the counterflow of something else, and that something was almost certainly connected to 3I Atlas. Just before the object disappeared behind the Sun, the James Webb Space Telescope captured spectroscopic traces of hydrogen emission trailing from its coma. But this wasn't ordinary hydrogen. It carried an unusual isotope ratio, with elevated deuterium levels far higher than those found in comets native to our solar system. A fingerprint from another star. If even a fraction of that material intersected Mars's path, the result would be exactly what MAVEN observed: a transient shell of alien hydrogen wrapping the planet. The shape of the veil was reconstructed from orbital passes not spherical, but spiral, like a winding ribbon coiling around Mars's poles. Each revolution matched the planet's 24.6-hour rotation, suggesting a resonant interaction between atmospheric motion and the incoming plasma. The veil seemed to twist as Mars turned, creating regions of faint ultraviolet glow that appeared and vanished in sequence, like rotating searchlights in the dark. By dawn on November 5th, the hydrogen density dropped back to normal. The veil lifted as silently as it had appeared. When the data was reviewed, scientists noticed something haunting. During the event, the thermal escape velocity of hydrogen at the upper boundary layer had fallen just below Mars's escape threshold. For a few hours, the planet had effectively sealed itself or been sealed from losing water vapor to space. The practical consequence was small. Mars didn't suddenly become habitable or moist. But conceptually, it was profound. For billions of years, Mars has been drying out, bleeding hydrogen into space molecule by molecule. On that night, something reversed the process, however briefly, as if the planet took one deep breath inward before exhaling again. The public never heard about the hydrogen veil. It appeared only in technical bulletins, buried beneath jargon. Transient isotopic enrichment, detected in upper atmosphere, source uncertain. Yet among planetary scientists, the implication lingered. If 3I Atlas could project a hydrogen field across millions of kilometers, enough to drape an entire world in another star's chemistry, then Mars wasn't just a bystander in its passage. It was a canvas, and for 6 quiet hours in November 2025, that canvas glowed faintly blue at the edge of space, painted by hydrogen that had traveled longer and farther than any human mission ever will. At 2:19 local time on November 7th, 2025, the Martian surface trembled, but not in any way we've ever recorded before. No rumble, no shockwave, no cascading frequencies rolling through the crust. Just a single, soft vibration that moved like breath beneath stone. It lasted 43 seconds, then vanished. If you hadn't been measuring for it, you'd never have known it happened. Yet on the instrument still listening, it left a signature that has no analogue anywhere in Mars's seismic history. The signal was captured by the SEIS seismometer, the last functioning relic of NASA's retired InSight mission. It was running in low-power hibernation mode, kept alive by the final trickle of current from a dust-clogged solar array. No one expected it to record anything. The system had been effectively dead for months. Then, inexplicably, its sensors woke, synchronized, and started logging data exactly as 3I Atlas reached its post-conjunction trajectory. The first time the interstellar object reappeared from behind the Sunday, the timing wasn't lost on anyone. At first, engineers dismissed the quake as data corruption, but when they filtered the noise, something remained a clean, coherent waveform repeating at intervals of 4.2 seconds. It wasn't jagged like a tectonic crack, or impulsive like an impact. It was smooth, harmonic, layered. Each oscillation decayed into the next, producing what geophysicists call a standing resonance. The entire reading resembled the echo of a tuning fork struck underwater. For days, analysts at JPL compared it against every known seismic source. No meteor impacts were detected by Mars Reconnaissance Orbiter. No pressure waves were logged in the thin atmosphere. The origin point triangulated to Elysium Planitia, the same flat plane where InSight had landed years earlier, but nothing on the surface had changed. No new craters, no dust plumes, no landslides. The ground had moved, but the landscape hadn't. The most puzzling part was depth. Seismic modelling suggested the vibration came not from the crust or the mantle, but from below, both roughly 1,600 kilometers down, near the boundary where the planet's core begins. That region should be inert, frozen solid by now. Yet during those 43 seconds, it pulsed. Each beat grew slightly weaker, then stopped entirely, leaving behind a silence even deeper than before. When the data was replayed through frequency mapping, a strange detail appeared. Every fourth oscillation contained a subtle frequency modulation, a tiny rise, then fall, of exactly 0.12 Hz. That's the same pattern seen in magnetosonic waves disturbances created when electromagnetic energy interacts with a magnetic field through ionized plasma. On Earth, such waves ripple through the magnetosphere during strong solar storms. On Mars, with its fractured magnetic remnants, they should be impossible, unless something external had induced them. That something might have been 3I Atlas. Simulations run at the European Space Operations Centre later showed that when the object crossed the heliospheric current sheet, it trailed a filament of charged particles, essentially a moving electric field. If even a fraction of that current brushed Mars, It could have induced a global electromagnetic pulse deep within the crust, strong enough to make the planet's metallic core momentarily oscillate. That would explain the smooth, harmonic nature of the waveform, a planetary-scale resonance excited by passing energy. For a brief moment, Mars may have hummed, not violently, but musically vibrating in sympathy with a force crossing interplanetary space. A soundless quake, because there was no air dense enough to carry the sound, yet a vibration nonetheless, the kind that speaks only through numbers. When the seismic data was overlaid with Maven's magnetometer logs, a chilling coincidence emerged. Exactly when the quake occurred, the orbiter detected a faint increase in local magnetic field strength, a fraction of a nanotesla, barely measurable, but real. The quake and the field pulse were synchronized down to the second, one in the sky, one in the stone. NASA never released a formal statement. Officially, the data remained under review. Unofficially, the event spread among researchers under a quiet nickname, the hum at the core. Some saw it as proof of magnetic induction. Others wondered if it was simply the planet responding to an external frequency, as if something had tuned Mars for less than a minute, plucked it like a string, then let it fade. By the time the SEIS seismometer powered down again, the surface had returned to silence. But the memory of that 43-second vibration endures in the data archives, a whisper from beneath a dead world, triggered by a visitor that never touched it. A reminder that even in the vacuum between planets, resonance travels farther than sound ever could. For most of its existence, Mars has barely breathed at all. Its magnetic field, once strong enough to shield oceans and atmosphere, collapsed billions of years ago. What remains today are only fragments, localized patches of magnetized crust scattered across the southern hemisphere, remnants of an ancient dynamo that fell silent. To scientists, that silence is permanent. Magnetism doesn't return once it dies, except in November 2025, it did. The Maven spacecraft was the first to notice. Its magnetometer, orbiting 6,000 kilometers above the surface, began recording an oscillation in the planet's magnetic tail, a slow expansion and contraction that repeated every 14 hours. At first, the rhythm was dismissed as interference from solar wind. The sun's magnetic storms often buffet Mars, causing temporary fluctuations. But these pulses were too regular, too steady. Solar winds come in chaotic gusts. This was a heartbeat. Within 2 days, multiple instruments confirmed it. The magnetic field lines trailing behind Mars were breathing, expanding outward into space, then collapsing back toward the planet like a living lung. Each inhale and exhale matched the same period recorded from 3 I-Atlas's rotational light curve: 14 hours, 2 minutes, 17 seconds. The interstellar object, still rounding the sun at extraordinary speed, was spinning with the same timing as Mars's new magnetic pulse. Coincidence? That word appears frequently in the official logs, yet the deeper the data was analyzed, the less accidental it seemed. Every breath in the Martian magnetotail corresponded with faint spikes in solar wind density, but only when those flows aligned with the projected coordinates of Atlas's plasma trail. The object, though millions of kilometers away, appeared to be modulating the sun's particle stream in rhythm with its own spin, and Mars, caught downstream, was responding. Visualizations from the European Space Operations Center painted a haunting picture. The magnetotail of Mars, a faint ghost-like streamer of charged particles, stretching millions of kilometers, was pulsing with waves that traveled at 400 kilometers per second, perfectly synchronized across hemispheres. No local process could account for that level of coherence. Even Earth's magnetosphere, far stronger, doesn't pulse with such symmetry. This was different. An external driver pressing softly, predictably, like the tide. Scientists scrambled for explanations. One theory proposed resonant induction, that Atlas's tail, saturated with charged nickel particles, was acting like a moving antenna inside the heliospheric current sheet. As it rotated, it periodically aligned with the sun's magnetic field, producing rhythmic surges in plasma density. Those surges propagated outward, brushing against Mars's fragile magnetic remnants and causing them to inflate and contract. If true, the planet wasn't generating magnetism on its own. It was borrowing it, resonating like a metal tuning fork struck by a distant hand. For the 6 days that followed, the breathing continued. Magnetic pressure rose and fell every 14 hours. distorting the planet's upper atmosphere. The auroral ovals near the poles flickered faintly with each pulse, as if the planet's lungs glowed each time it inhaled. Then, abruptly, the pattern stopped. The final oscillation was recorded at 2:17 UTC on November 13th, after which the field flattened to its usual irregular baseline. The silence returned as quickly as it had vanished. What remained were the trace's thin fingerprints of organized magnetism moving across the Martian sky. When researchers transformed the data into an audible sonification, the result was unnerving. A slow, rising hum followed by a deep exhale, repeating again and again. They called it the sound of a dead planet remembering how to breathe. In later months, when 3I Atlas was long gone, Maven continued to record minor echoes of the same rhythm. Every few sols, a faint pulse would ripple through the magnetotail, as if Mars still held the memory of that external touch. The amplitude was weaker each time, decaying into background noise, but the timing never changed. 14 hours, 2 minutes, 17 seconds. Always that number. No one has officially linked the two phenomena, but in internal reports the connection is impossible to ignore. When an object from another star system entered the heliosphere, Mars, long thought geophysically dormant, pulsed in perfect synchrony. It was as if the two were communicating in physics rather than words, exchanging signals written in magnetism instead of light. Perhaps it was a coincidence, or perhaps 3I Atlas carried with it not only mass and motion, but frequency, a rhythm capable of waking echoes in the cores of silent worlds. And for a few strange days in 2025, Mars breathed again, not with air, but with magnetism. It began as a rumor among amateur astronomers, a faint, impossible shimmer on the night side of Mars. For days no one believed it. Mars doesn't glow blue. Its atmosphere is too thin, its chemistry too red. Yet photographs taken on November 15th, 2025, by a cluster of deep sky observers in Chile and Spain, all showed the same thing. A pale electric halo ringing the planet's equator, visible even through the solar glare. Within hours, observatories across the world turned their optics toward the anomaly, and what they saw made silence fall across entire control rooms. At first glance, it looked like aurora, a circular band of faint light encircling the mid-latitudes, luminous and steady. But it wasn't confined to the poles, and it didn't flicker like charged particle storms do. It shimmered uniformly, as if the whole planet had been wrapped in a continuous shell of energy. Spectrographs quickly revealed the truth. The emission line was centered near 420 nanometers, the wavelength of ionized argon gas. That shouldn't have been possible. Argon exists on Mars, yes, about 1.9% of its thin atmosphere, but it doesn't ionize easily. It takes enormous energy to strip electrons from its atoms, and there was no event capable of supplying that energy. No solar flare, no magnetic storm, just the blue. The Maven orbiter recorded the phenomenon in exquisite detail. Its ultraviolet spectrometer showed a sudden spike in atmospheric excitation beginning over Valles Marineris, the planet's massive canyon system, and spreading outward like ripples in water. Within minutes, the glow extended around the entire globe, peaking in brightness over the Western Hemisphere. Then it stabilized, a gentle, steady luminescence visible for nearly 40 minutes. To ground observers, it looked as though Mars had grown a second atmosphere, thin, translucent, pulsing faintly against the blackness. When data from the trace gas orbiter arrived, things grew stranger. The pattern of ionization didn't follow the shape of Mars's crustal magnetic fields. Instead, it mapped perfectly onto the predicted heliospheric current lines intersecting the path of 3I Atlas. The alignment was exact, the same angular offset, the same arc across longitude. It was as though a filament of charged gas, thrown off by the interstellar object weeks earlier, had brushed against Mars and left it glowing in response. ESA scientists tried to reproduce the event in simulations. They modelled argon excitation caused by solar wind compression, dust storm friction, even micrometeor impacts. None matched the observed spectra. The only input that produced the correct light signature required a pulse of high-energy plasma moving at 70 kilometers per second, striking the upper atmosphere at a shallow angle, precisely the velocity of 3I Atlas at perihelion. That realization sent quiet shockwaves through the research community. If the numbers were right, the glow wasn't self-generated. It was induced. From Mars's surface, Perseverance's cameras caught only a subtle shift, a ghostly tint at the horizon, faint enough to evade casual notice but unmistakable in analysis. Pixel by pixel, scientists isolated the same 420 nanometer signature. For those 37 minutes, the Martian dusk had turned sapphire. Even the shadows had changed tone. And then, as suddenly as it appeared, the light faded not in patches, but everywhere at once, as if switched off. Theories multiplied. Some called it an atmospheric resonance, others a reflection from passing solar plasma. But the timing with Atlas's perihelion, the object's closest and fastest approach to the Sun, was too precise to ignore. In the span of that single day, Atlas's magnetic field, faint but measurable, had aligned with Mars's orbital plane for the first and only time. For less than an hour, both worlds shared the same electrical geometry, and Mars had lit up like a signal. When scientists converted MAVEN's ultraviolet data into audible sound, the result was haunting. A low hum rising into a harmonic overtone, fading like a sigh. Some described it as the sound of plasma folding back into vacuum. Others, less poetic but no less awed, noted that the hum's fundamental frequency matched Atlas's 14-hour rotational rhythm, divided by its orbital ratio, the same pattern seen in the earlier magnetic breathing. Mathematically elegant, physically improbable. Officially, NASA classified the event as a transient luminescent plasma coupling. Unofficially, it became known as the blue halo, a phrase whispered in mission logs and late-night calls between labs, because for the first time since its magnetic field died, Mars had shone with the light of interaction not from its own physics, but from something passing by. The glow had carried no heat, no danger, no voice, only information, written in blue across the silence of space. And when it faded, every instrument watching went quiet too, as if the entire solar system had held its breath waiting to see whether Mars would answer back. Cameras don't blink. They can be damaged, saturated, or shut off, but they don't close their eyes. That's why the event that engineers later called the camera blindness is so unsettling. On November 16th, 2025, just one day after the blue halo vanished, both of NASA's active surface missions, Perseverance in Jezero Crater and the small, aging Ingenuity, helicopter resting nearby, experienced a simultaneous optical blackout. For exactly 3 minutes and 49 seconds, every active camera on board both systems recorded pure white. No overexposure gradient, no lens flare, no cosmic ray streaks, just uniform brightness, as though the entire visible world had been erased. At first, it was filed as a transmission error. Perseverance sends thousands of image packets daily, many of which are corrupted by dust interference or weak bandwidth. But when telemetry was reviewed, something didn't add up. The rover's environmental sensors continued functioning perfectly throughout the gap. Wind readings, battery voltage, internal temperature, all normal. Even the microphones captured faint ambient hum, the same low Martian wind that always murmurs across the crater. Only the visual sensors failed. The anomaly affected every optical device simultaneously. Mastcam Z, Navcam, and even the microscopic Watson imager on the robotic arm. Each showed a flat white field, exactly identical down to the digital noise pattern, a statistical impossibility if caused by a random glitch. More disturbing, Ingenuity's downward-facing navigation camera, operating independently, showed the same blank frames during the same time window. Two separate systems, two separate power sources, both blind in unison. Mission Control assumed a localized dust flash, perhaps sunlight reflecting off airborne particles after a micro-landing disturbance. But Perseverance hadn't moved. Its wheels were locked, its arms stowed. There had been no motion, no vibration, no mechanical activity. And yet the light sensors had gone completely white. Hours later, when the raw data was reconstructed, another clue appeared. The frames preceding and following the whiteout showed subtle blue scattering on the horizon, the faint residue of the same wavelength seen during the blue halo event. The timing was too close to ignore. In fact, the first white frame was time-stamped exactly 27 seconds after MAVEN recorded the final ultraviolet pulse from Mars's upper atmosphere. Whatever ended the blue halo had immediately rendered the planet's cameras blind. Engineers proposed an electromagnetic cause. If a sudden burst of charged particles had flooded the local environment, it could have overloaded the image sensors. But there was a problem. The rover's electronics are heavily shielded, and its HAZCAM systems have survived direct cosmic ray hits without losing synchronization. No known solar or cosmic event was powerful enough to produce a planet-wide optical washout without damaging other systems. The cameras had gone blind, but only visually, and only briefly, as if the world had stopped reflecting light. Weeks later, data from the Trace Gas Orbiter offered an overlooked piece of evidence. During the same 3-minute window, the orbiter's spectrometer showed a sharp drop in reflected sunlight intensity across the entire disk of Mars. The planet itself had dimmed. Then, almost instantly, the brightness returned, not fading in, not recovering, gradually switching on, like a light restored after blackout. Researchers at the European Space Astronomy Centre built models of what could cause such instantaneous dimming. The most plausible scenario involved a temporary polarization of atmospheric particles, creating a momentary mirror that scattered incoming sunlight away instead of downward. That mirror would have been invisible from Earth, but blinding from the surface, where light would arrive from every direction simultaneously. In other words, Mars might have been wrapped for 3 minutes in a perfect optical shell, turning day into omnidirectional white. If true, then what Perseverance and Ingenuity saw, or didn't see, wasn't emptiness, but reflection. Every photon hitting the planet during that period bounced outward, including the ones from their own navigation LEDs. They had effectively looked into infinity. Official documentation later referred to the incident as a localized saturation anomaly. Unofficially, the engineers called it the blink. Some joked it was Mars closing its eyes after the blue halo, as though the planet needed to shield itself from what had just touched it. The cameras rebooted normally afterward. No damage, no errors, no explanation. But buried in the diagnostic logs was one final curiosity. The rover's light sensors recorded an electromagnetic phase shift during the whiteout, a measurable lag between photon arrival and electronic response, on the order of microseconds, not enough to be dangerous, but enough to prove the light they received wasn't normal sunlight. For those 3 minutes and 49 seconds, Mars didn't just blind the cameras, it redefined what light meant. And when the world returned, it was as if nothing had happened, except for one lingering fact. Every lens on that planet, mechanical or human-made, had seen absolutely nothing together. Static is never random. It may sound like noise, but hidden within every hiss and crackle is structure, a story about the energy that produced it. That's why, when engineers at the European Space Operations Centre began hearing static in data transmissions from ESA's Trace Gas Orbiter on November 18th, 2025, they didn't dismiss it as background interference. They listened. The anomaly began during a routine downlink session between TGO and Earth. Every few minutes, faint pops and bursts interrupted the stream, irregular at first, then rhythmic. The static grew stronger as the orbiter passed over Mars's northern hemisphere, peaking each time it crossed the planet's terminator line between day and night. By the 5th orbit, the noise had turned into something unmistakable, a pattern. Telemetry logs show it started as brief electrical spikes, microcurrents building up along the orbiter's high-gain antenna. Normally, Mars's thin atmosphere is too diffuse to produce significant electrostatic discharge, but these voltages were intense, comparable to what the probe would experience flying through a sandstorm. Yet below, the skies were clear. No dust, no storms, no lightning. The source had to be external. The spikes came in clusters of 5, repeating every 62 seconds, a period that baffled analysts. Solar wind fluctuations follow chaotic rhythms, not clockwork, and the signal's polarity flipped each cycle, alternating between positive and negative charge. It wasn't natural turbulence. It was an alternating field, a push, a pull, a steady oscillation of invisible force that seemed to breathe with purpose. Maven's magnetometer provided the next clue. At the same time the static was peaking, it detected fine-scale ripples in magnetic pressure, sweeping through Mars's upper atmosphere, waves too small to register as storms, but too large to be mere noise. When the two datasets were synchronized, the result was clear. Each pulse of static on TGO matched a magnetic oscillation detected by Maven half a planet away. Two separate spacecraft, operating on different frequencies, were recording the same heartbeat. The natural explanation was that Mars was passing through a flux tube, a column of electrically charged plasma connecting it temporarily to the solar wind. But the direction was wrong. The current wasn't flowing from the Sun to Mars. It was flowing from Mars outward. In essence, the planet had turned itself into a weak transmitter. When scientists plotted the orientation of those magnetic ripples, they pointed directly along the trajectory of 3I Atlas, now just beyond Mars's orbital path, moving toward the asteroid belt. It was as if Mars and the interstellar object were still tethered by an invisible cord, an electromagnetic afterimage left in the vacuum. The pattern lasted for nearly 4 hours before fading away. During that time, instruments on the ExoMars Trace Gas Orbiter recorded intermittent current discharges along its solar panels. Static flashes bright enough to overload its optical sensors. Engineers feared hardware damage, but the equipment survived. When the voltage dropped to normal levels, the static noise vanished as abruptly as it had begun. And yet, in the archived audio files of the downlink transmission, something strange remains. When amplified and slowed down, the static resolves into a faint, pulsing tone. 5 quick bursts, a pause, then another 5. Each group identical, each separated by exactly 62 seconds. Nobody calls it a message, but it's difficult not to think of it that way when the sequence repeats with such precision. If it was random, it was the most disciplined randomness ever recorded in Mars orbit. Post-event analysis suggested that the alternating charge might have been caused by charged dust grains trapped temporarily in Mars's magnetotail grains, possibly derived from the metallic debris of 3I Atlas's tail. Under this theory, the grains became aligned by the planet's weak electric field, forming a drifting sheet of conductive particles that oscillated as the solar wind shifted direction. For a few hours, that sheet turned Mars into a gigantic capacitor, building and releasing electrical energy into space. The official report labeled it transient electromagnetic interference due to fine-grained plasma interaction, but within the control rooms no one used the formal term. They called it the static field, a veil of invisible electricity that wrapped Mars in a hum. For those who monitored it live, it felt eerily sentient. Each pulse arrived with the predictability of breath, as if the planet were exhaling charge into space, not just noise, but rhythm. And when it stopped, the silence afterward felt heavier than before, like the air after thunder, because for those 4 hours in November 2025, Mars didn't just reflect light or magnetism. It spoke. In static, every planet leaves a faint wake behind it, a thin ribbon of dust and ions shaped by its motion through the solar wind. For Mars, that wake has always been stable, predictable, and faint. But in mid-November 2025, something began moving through it that shouldn't have been there. The MAVEN spacecraft first noticed the anomaly during its orbital sweep on November 21st, just a week after the static field incident. Its neutral gas and ion mass spectrometer detected clusters of micron-sized particles drifting ahead of Mars's bow shock, that invisible frontier where the solar wind crashes against the planet's magnetosphere. Normally, particles in this region move in alignment with the flow of solar plasma, streaming away from the sun like dust in a current. But these weren't obeying that rule. They were moving the wrong way upward, against the solar flow, as if being drawn towards something unseen above the planet. At first, analysts thought it was an instrumentation glitch. Tiny voltage fluctuations in MAVEN's sensors can make it appear as though dust is flowing backward, but when the Trace Gas Orbiter passed through the same region just 2 hours later, it recorded identical readings. The measurements agreed to within 0.5%, a perfect confirmation that the effect was real. The drift began subtly. Individual grains, perhaps a few hundred nanometers wide, were being accelerated in microbursts, gaining velocity not outward, but inward toward Mars. For several hours, MAVEN tracked streams of these particles, forming narrow, glowing ribbons above the northern hemisphere. Under ultraviolet imaging, they appeared as faint blue threads looping and curving like filaments of silk. The structure looked artificial, though no one dared to use that word publicly. Scientists compared the velocity vectors to the orbital path of 3I Atlas, which by then had passed beyond Mars and was speeding toward the asteroid belt. The correlation was striking. The drift direction matched the residual trajectory of the comet's plasma tail, but reversed. It was as though the debris Atlas had left behind was now being pulled back, magnetically retracted like the ebb of a tide. ESA's data scientists ran simulations to see what could cause such behavior. The only plausible model involved a magnetized particle field, still resonating with the periodic pulse of Atlas's tail, the same 14-hour rhythm that had driven the magnetic breathing earlier in the month. When that frequency intersected Mars's residual electromagnetic field, It created zones of alternating attraction and repulsion. Particles caught in those zones would oscillate between drift directions, appearing to dance against the wind. For the next 8 hours, MAVEN's sensors recorded what can only be described as choreography in space. Streams of metallic dust rose and fell in waveforms, folding back over themselves with mathematical precision. Each loop peaked at the same altitude, 220 kilometers above the surface, the exact boundary where Mars's exosphere meets the solar wind. The movements weren't random turbulence. They formed repeating spirals, echoing the shape of Atlas's own double helix plasma tail observed weeks earlier by the James Webb Space Telescope. Then, without warning, the pattern collapsed. At 1722 UTC, the drift reversed one final time, scattering outward in every direction. The sensors recorded a sharp drop in particle density as if something had absorbed the field entirely. Within 20 minutes, the readings fell to baseline. The drift was gone. The aftermath, however, left questions. MAVEN's onboard electrostatic analyzers showed a residual charge on the spacecraft's solar panels, the kind that builds only when exposed to alternating electric fields. That charge lingered for days, slowly bleeding off into the void. Even after the dust dispersed, the energy it carried remained imprinted in the environment, invisible but measurable. One theory gained quiet traction in the days that followed, that the drifting particles weren't being pulled by gravity or magnetism alone, but by an electrostatic echo from Atlas's plasma wake, a low-frequency oscillation still propagating through interplanetary space long after the object had passed. If true, that would mean the interstellar visitor had left a field memory, a temporary distortion capable of influencing matter across millions of kilometers. NASA's official summary avoided the term entirely. The event was logged blandly as transient particle inversion, likely due to solar wind compression, but privately, researchers began calling it the particle drift, a phrase that captured both its beauty and its mystery. For 8 hours on a silent planet, grains of dust had moved, as though obeying a conductor no one could see, a choreography that mirrored the rotation of an object already gone, and when it ended, the dust fell still, leaving behind only the faint electromagnetic echo of something far greater passing through. Mars had been brushed by an interstellar rhythm, and, for a moment, it had swayed. On November 23rd, 2025, the Hubble Space Telescope captured an image that defied every expectation of orbital optics. Mars was crossing the edge of its solar conjunction, faint but still visible, a dull ember on the horizon of the Sunday. But in the frame that followed, something appeared that shouldn't exist in the vacuum of interplanetary space. A narrow, vertical streak of light, deep crimson, rising from Mars and extending sunward. It wasn't a camera artifact or cosmic ray hit. It had structure, consistency, and reflection geometry. And whatever it was bright enough to register across multiple exposure levels. Astronomers first thought it might be scattered sunlight bouncing off a passing dust cloud. That explanation failed immediately. There was no corresponding dust signature in infrared imaging, and the streak remained visible even in ultraviolet. Something solid, or at least cohesive, was reflecting light directly from the sun, and the reflection was tinted red. The phenomenon lasted only 7 hours, but during that brief window, 3 separate observatories, Hubble, Goldstone, and the Subaru telescope in Hawaii, recorded it independently. Each dataset showed the same alignment. The red streak emanated from a point roughly 2,000 kilometers above the Martian equator, extending outward at a 15-degree angle toward the Sunday. When triangulated, the feature was roughly 800 kilometers long and appeared stationary relative to Mars. Nothing natural behaves like that. By cross-referencing the data, scientists discovered the streak spectrum was highly specific. It emitted a strong line at 656.3 nanometers, the H-alpha line of excited hydrogen, the same wavelength used by astronomers to study solar prominences. But Mars's upper atmosphere doesn't contain hydrogen dense enough to produce visible H-alpha reflection. Something else was amplifying it. That something might have been metal. When ESA's trace gas orbiter pointed its spectrometer toward the region, it detected traces of nickel and chromium ions, both of which are strong reflectors in the red spectrum. These elements matched the known ejecta composition of 3 I Atlas, observed weeks earlier, when the object's tail first ionized under sunlight. The conclusion was difficult to avoid. A thin metallic veil, perhaps dust or plasma, was lingering near Mars, catching sunlight and refracting it into the red beam Hubble had seen. But the reflection didn't behave like a simple scatter field. It moved. Across several hours, the streak slowly bent and coiled, as though twisting under invisible tension. Its upper end oscillated by nearly 10 degrees, while the base remained anchored to the same altitude. That oscillation had a period of 14 hours and 2 minutes, the same rotation cycle of 3 I-Atlas. The comet was already tens of millions of kilometers away, yet somehow its old rhythm persisted in the Martian sky. At ground level, Perseverance's sky camera captured faint red glints across the horizon. They weren't visible to the naked eye, but appeared as pulses of light at consistent intervals. When translated into audio frequencies, those intervals formed a slow, even cadence like a mechanical heartbeat. The rover's sensors also logged a brief surge in local radiation, just high enough to ionize dust around its mast. For 5 minutes, the air above Jezero crater literally glowed, thin but measurable. After 7 hours, the reflection vanished without fading. It didn't dim, it simply snapped off, as if a light source had been cut. No residual glow remained, no trace particles, no thermal residue. Even the orbiter's instruments went silent simultaneously, registering a momentary drop in signal noise, as if space itself had exhaled. Researchers debated for months. Was the red reflection an ion plume triggered by solar wind turbulence? A mirage of refracted light bouncing along residual plasma trails from Atlas? Or could it have been a temporary magnetic mirror, focusing solar radiation through the charged metal dust still orbiting Mars? One model, buried in a quiet internal ESA paper, offered the most startling hypothesis. If 3 I-Atlas's dust contained enough ferromagnetic material, it could have briefly aligned with Mars's weak magnetic remnants, creating a column of magnetized plasma, effectively a cosmic antenna, reflecting red-shifted light toward the Sunday. That would make the red reflection not a beam, but a signal return light traveling back along the same corridor the object had once traversed. NASA's public explanation was cautious. Transient plasma reflection event. Cause undetermined. But among scientists who work the data directly, the mood was different. They spoke of it as though Mars had briefly answered back, a red echo sent toward the same star that illuminated it, following the path of a visitor from another system. It didn't speak in radio waves, or heat, or gravity. It spoke in reflection, a streak of red light, perfectly vertical against the void, lasting just long enough to be recorded and never repeated. And in that moment, for those who saw it, Mars looked less like a dead planet, and more like a mirror one that had for the first time caught a glimpse of itself in another world's light. In the aftermath of the red reflection, scientists turned to data desperate for something measurable, something solid to hold on to. What they found instead only deepened the mystery. On November 25, 2025, NASA's Mars Climate Sounder aboard the Mars Reconnaissance Orbiter began mapping the planet's upper atmosphere for temperature and pressure. It was routine work, part of a scheduled update to refine global climate models, but when the first composite maps were generated, the data didn't look like atmosphere at all. It looked like geometry. The pressure gradients, normally chaotic and diffuse, had formed a spiral pattern centered near 40 degrees north latitude, just east of the Tharsis volcanic region. Concentric rings of slightly higher and lower pressure radiated outward, perfectly symmetrical, rotating clockwise. Each ring was spaced by about 1,200 kilometers, and the pattern extended across half the planet. Mars doesn't make shapes like that. Its weather is driven by dust, solar heating, and thin air turbulence, messy, non-linear, unrepeatable. This spiral was almost architectural. At first, analysts thought the readings were corrupted by instrument noise, but when the ExoMars trace gas orbiter cross-checked the same altitudes, it recorded identical fluctuations in density. Even MAVEN, flying at a completely different orbital inclination, saw the same pattern forming in the ionosphere, a vast rotating pressure wave circling Mars like a slow, invisible cyclone. Except it wasn't moving with the wind. It was moving with the magnetic field. When magnetometer data was layered over the pressure maps, the alignment became undeniable. Each ring of the spiral matched a region of alternating magnetic polarity, positive and negative, repeating like ripples from a pebble dropped into a pond. But these ripples didn't spread outward evenly. They followed the exact orientation of the heliospheric current sheet, the Sun's immense electromagnetic veil that runs through every planet's orbit. That geometry traced directly back to one object's path, 3I Atlas. The Discovery stunned mission control. Pressure gradients don't usually track magnetic geometry. Gases and fields exist in separate regimes, yet here was evidence that something had coupled them, turning Mars's thin air into a visible record of electromagnetic interference. It was as though the planet's atmosphere had been printed on by the passing of an interstellar field. Scientists at the European Space Astronomy Centre recreated the event in simulation. They found that if a large enough plasma body, such as the ionized tail of 3I Atlas, brushed through Mars's magnetotail at the correct angle, it could induce resonant standing waves in the planet's upper atmosphere. These waves would appear as alternating zones of high and low pressure, forming a spiral if the driving field rotated, while the planet turned beneath it. That's exactly what the data showed. Mars had become a barometer for alien magnetism. The amplitude of the waves was small, only a few pascals of difference between crests and troughs. Yet it was global in scale. Imagine a heartbeat big enough to move air across an entire planet, but gentle enough that you'd never feel it. The phenomenon persisted for almost 36 hours, gradually fading as solar wind intensity increased and the pattern dissolved into chaos. But while it lasted, the spiral symmetry was mathematically perfect. Each revolution completing every 14 hours, down to the minute again, matching 3I Atlas's rotation. When the visualization was converted into animation, researchers saw something that stopped them cold. The spiral didn't simply rotate, it pulsed, compressing and expanding with each turn, like lungs inhaling and exhaling across the whole Martian sky. The same slow rhythm seen in the magnetic breathing, the same timing echoed in every subsequent anomaly. The final map overlay compared Mars's pressure waves to the Parker Solar Probe's data from a month earlier, when it had recorded distortions in the solar wind caused by 3I Atlas's entry into the inner system. The geometries matched exactly same rotation, same wavelength spacing, same harmonic falloff. What Parker saw near the Sun, Mars was now repeating, delayed by time and distance, as if the planet had absorbed and replayed the comet's own electromagnetic fingerprint. NASA's public report called it a nonlinear atmospheric resonance event, but in private, researchers referred to it simply as the pressure maps, a phrase that felt more like a warning than a description. Because when they overlaid the spiral pattern on a map of Mars's crustal anomalies, they realized the spiral's center, its perfect eye, lay directly above Elysium Planitia, the same plane where InSight's seismometer had recorded the soundless quake just weeks earlier. Two different instruments, two different phenomena, one exact coordinate. Something beneath that plane had reacted twice to something above it. The team never found a definitive cause, but in the closed-door debrief that followed, one veteran atmospheric physicist summed it up quietly. Pressure doesn't draw patterns like this unless it's being told where to go. He was not Rangers, the fest of the snow, and on that day, in late November 2025, it looked as though Mars had been listening, tracing invisible instructions left behind by a traveler from another star. By the time the spiral pressure waves began to fade, one more anomaly had already appeared not on Mars but on Earth. For 12 consecutive days, starting November 27th, 2025, the European Space Agency released no public updates from its Mars missions. No daily telemetry summaries, no press releases, not even a tweet. It was as if the agency had collectively gone mute. The blackout began quietly. A routine weekly bulletin from Mars Express was scheduled to post at 9 CET on the 27th. It never appeared. Then, the ExoMars Trace Gas Orbiter's science dashboard, normally refreshed every 24 hours, froze at a single timestamp, the 26th of November 2025-22. 14 UTC, the same hour Maven recorded the final pulse of the planetary pressure spiral. After that, no new datasets reached the public repositories. Even the automated telemetry feed that tracks spacecraft power levels stopped updating. At first, nobody outside ESA noticed. Holiday schedules, staff rotations, and data uplink congestion could easily explain a short delay. But as days passed, amateur analysts, who had been following the 3I Atlas anomalies obsessively, began to point out the pattern. All three European spacecraft, Mars Express, TGO, and even Bepi Colombo, which was on its way to Mercury, had simultaneously stopped broadcasting public logs. The odds of that happening by coincidence were effectively zero. By December 1st, The silence had become impossible to ignore. Journalists began contacting ESA's Public Affairs Office, only to receive identical responses. Data transmission is being reviewed for calibration consistency. Is not true 4Cs. 4Cs play as the raptor, no further comment. Behind the scenes, however, something was happening. Insiders later described it as a containment phase, a moment when engineers and scientists were ordered to pause all external communication until the new readings from Mars could be verified for anomaly cross-contamination. That phrase anomaly cross-contamination made no sense to anyone outside the agency. Telemetry doesn't contaminate. It either arrives clean or it doesn't. But what the engineers were facing wasn't noise. It was pattern. Leaked excerpts from internal memos later revealed that several instruments aboard Mars Express and TGO had recorded spectral interference across multiple sensors, identical harmonic tones, repeating every 84 seconds. The interference wasn't random radiostatic. It carried phase structure, like a signal bouncing within the electronics themselves. When technicians ran the data through filters, they found an embedded waveform, a rhythmic oscillation encoded in the background noise of their own instruments. The waveform's timing corresponded precisely to the end of the pressure map spiral. One line from the memo read, "Spectral contamination appears self-sustaining, not external. Possible instrument feedback from prior exposure to electromagnetic resonance event." In other words, the probes might have been ringing, still vibrating with energy from whatever field had swept past Mars days earlier. The effect wasn't damaging, but it made every dataset unreliable. Pressure, temperature, even simple altitude readings showed faint oscillations. Until engineers could prove that these weren't real atmospheric signals, ESA had no choice but to lock down communications. That lockout lasted 12 days. No public images, no science briefings, no telemetry. Just silence. Inside Mission Control, staff worked in rotating night shifts, isolating instrument clusters, recalibrating sensors one by one, and on December 8th, just before the embargo lifted, a curious detail emerged. When the orbiter's data were finally purged and resynchronized, the harmonic tone disappeared, but only after the probes passed through Mars's nightside shadow. Something about darkness, about isolation from the sun's charged radiation, had broken the loop. It was as if whatever energy had lingered there needed sunlight to survive. When ESA's servers finally resumed updates on December 9th, nothing in the public statements hinted at the crisis. The new bulletin spoke blandly of scheduled calibration procedures and solar conjunction interference. But the datasets told another story. Dozens of instrument readings had been scrubbed or replaced with synthetic filler values, flat lines that didn't match the continuity of prior days. A quiet redaction of history. To outsiders, it was a brief technical pause. To those inside, it was a deliberate act of erasure. The only way to stop the resonance from spreading further through the data pipeline. A handful of scientists later admitted that they'd been instructed to avoid speculative correlation with non-terrestrial sources, a thinly veiled reference to 3I Atlas. In retrospect, the timing says everything. The silence began hours after the pressure maps reached their peak, and it ended the same week NASA's magnetometer logs returned to normal. Whatever swept through Mars in those days had left the instrument singing long after the music stopped. Officially, ESA's pause will always be explained as maintenance. Unofficially, among those who were there, it became known simply as the silence. A moment when Europe's most advanced spacecraft fell quiet, not because they'd failed, but because they might have been listening back. And for those 12 days, Mars was the loudest silent world in the solar system. When ESA's silence finally broke and data began flowing again, the scientific community rushed to make sense of the preceding month. The red light, the spirals, the hums, the static. In the span of 4 weeks, Mars had exhibited more unexplained phenomena than in the previous 4 decades of observation combined. Something had passed by that defied the simplicity of coincidence. And so, the theories began. They fell into 3 broad camps: natural, systemic, and intentional. Each offered comfort to a different kind of mind, and none could fully explain everything. The naturalists went first, those who refused to believe that the laws of physics had been rewritten. To them, every strange signal could be traced to solar activity. Yes, the sun had appeared calm in visible light, they argued. But solar wind behavior is complex. Invisible waves of magnetized plasma can travel through the heliosphere unnoticed until they strike a planet's weak magnetosphere. Mars, with its fractured magnetic remnants, would respond dramatically to such inputs. Resonant fields, pressure ripples, even luminous discharge events like the blue halo. The correlation with 3I Atlas's passage, they said, was merely a case of perfect timing, a solar cycle aligning by accident with a visiting object. It was the easiest answer to live with, and the one that fit most comfortably into official reports. The systemic camp was less forgiving. They believed the anomaly wasn't cosmic at all, that it originated from within the instruments themselves. Years of constant bombardment by cosmic radiation could create micro-defects in sensors, amplifying noise into patterns that only appeared meaningful. To them, the synchronized oscillations and 14-hour periodicities were artifacts of cross-contamination between overlapping telemetry systems. MAVEN, TGO, and Mars Express were never designed to operate in electromagnetic unison. When forced to coordinate during solar conjunction, they may have simply begun echoing each other's errors. The entire interstellar influence, they claimed, was nothing more than 3 aging spacecraft locked in feedback with their own data. It was an elegant, human-centered theory, comforting in its implication that the universe remained stable, and only our tools were haunted. But then came the third group, the quiet minority who met after hours, trading encrypted messages and private notes. They didn't publish papers. They built timelines. To them, the events were too sequential, too ordered to be chance. A wave of hydrogen on November 4th, the magnetic breathing on the 9th, the blue aurora on the 15th, the red reflection on the 23rd, each step like a progression in a deliberate pattern. They pointed out that many of the anomalies followed the same rotational rhythm. 14 hours, 2 minutes, 17 seconds, 3I Atlas's measured spin rate. How could a comet's rotation, observed weeks earlier, leave rhythmic fingerprints in Mars's atmosphere unless something about that rotation was being broadcast or received? The more cautious among them proposed a magnetic resonance theory. If Atlas's nucleus contained ferromagnetic minerals aligned by motion, it could have acted like a natural generator, modulating the interplanetary magnetic field in a pattern. That modulation might have synchronized with planetary magnetic anomalies, briefly coupling energy into Mars's core and atmosphere, a kind of cosmic feedback loop between worlds. The result would look like communication, even if it were only physics. But others, quietly and carefully, took it further. They asked why Atlas's plasma tail had behaved unlike any comet ever observed, structured, coherent, and rich in metallic ions. They asked why the electromagnetic effects continued even after the object had vanished beyond Mars's orbit. And they asked why ESA, an agency renowned for transparency, had gone silent exactly when those effects peaked. To them, these weren't accidents. They were responses. The comet's passage, the planet's glow, the magnetic resonance together, they formed not chaos but sequence. The pattern resembled a transmission. Pulse, echo, feedback, silence. Among the classified correspondence between agencies, one line stood out, a phrase written by an unnamed analyst in an internal NASA memo dated December 12, 2025. The observed anomalies could represent a coupling event, the energetic equivalent of a handshake. It was never explained further. Whether metaphor or literal suggestion, the phrase captured the tension of that winter. Had Mars been touched by something? Or had it simply resonated with energy it didn't understand? No consensus ever emerged. Every explanation could account for some part of the mystery, but not all. Natural physics couldn't explain the synchrony. Instrumental feedback couldn't explain the atmospheric glow. And intentional resonance, the idea of message through motion, could explain everything, but at the cost of rewriting what humanity thought was possible. By year's end, all 3 theories stood in uneasy coexistence, like layers of sediment covering an unanswered question. Each scientist chose the one they could live with, but in the quiet moments between debates, when the data screens dimmed and the noise faded, many of them admitted privately that they still felt it, that faint, pulsing rhythm at the edge of their instruments, as if Mars hadn't stopped responding yet. By December 2025, Mars had gone still again. The blue halo had faded, the red reflection was gone, the magnetic breathing, the spirals, the hums, all vanished. For a while, it seemed the planet had returned to its old silence, the quiet of dust and thin air. Then, one night, the instruments began whispering again. It started on December 19th, when the Mars Reconnaissance Orbiter, MRO, performed a scheduled data relay with the Perseverance rover. The transmission appeared normal until engineers noticed something buried in the signal. An unexplained phase delay, a fraction of a millisecond stretching across every packet. It wasn't corruption. It was timed. Each packet arrived exactly 14 hours, 2 minutes and 17 seconds apart, the now familiar rhythm of 3 I-Atlas. Someone joked that the comet had left its signature in the communication link itself. No one laughed for long. The following day, Maven's magnetometer picked up faint pulses once again in the planet's night-side tail. Too weak to be visible, too structured to be random. Each pulse matched the frequency recorded during the original magnetic breathing in early November. It was as though the planet had taken a deep breath weeks ago, and was now exhaling. The readings repeated daily. Small, almost imperceptible bursts of ionized particles drifted from Mars's upper atmosphere toward interplanetary space. To most instruments, they looked like noise, but when plotted over time, the emission formed a sinusoidal pattern, a perfect mirror of the earlier waveforms. Whatever force had once pressed into Mars was now leaking back out. At first, Mission Control dismissed it as a delayed solar interaction. But then, on December 22nd, something else changed. The Mars Climate Sounder, orbiting high above the planet, detected a faint increase in infrared emissions near Elysium Planitia, the same plane that had been the epicenter of the soundless quake and the core of the pressure map spiral. The anomaly covered roughly 600 square kilometers, small but distinct. Nighttime surface temperatures rose by nearly 7 degrees Celsius. No dust storm, no meteor impact, no geothermal explanation. It was simply warm in one spot, for no reason. ESA's trace gas orbiter turned its spectrometers toward the region. What it found shouldn't have existed. The air above Elysium contained a narrow layer of ionized hydrogen and nickel particles, the exact chemical fingerprint of 3 I-Atlas's tail. But the comet was now hundreds of millions of kilometers away. No new material should have reached Mars. Somehow, the trace elements had reconcentrated as if the planet itself had exhaled them. The event lasted less than 2 hours. When it ended, all readings returned to normal except one. The magnetometer aboard Maven continued detecting faint oscillations, this time emanating from Mars itself, not the surrounding plasma. It was as though the planet's crust had retained a charge and was now slowly releasing it. Every few hours, the signal pulsed quiet, rhythmic, deliberate. Within ESA, a few analysts began calling it the re-emergence. They described it as an echo, a second act of a performance that had already ended. But others noticed a pattern. The timing of the pulses coincided exactly with Mars's rotation. Each time the planet turned the same longitude beneath the Sun, specifically the region near Elysium, the signal returned. It wasn't continuous. It was locked to place. By December 27th, several ground-based radio telescopes on Earth reported faint, transient bursts coming from Mars's direction. They were far too weak for official confirmation, buried in the galactic background, but the correlation was undeniable. The same 14-hour pattern, the same waveform shape, as if the resonance that had once travelled from Atlas to Mars was now being broadcast outward, reversed, reflected. NASA and ESA jointly agreed to halt all active radar transmissions to the planet until the cause was understood. The public explanation was careful. Solar interference may have induced cross-resonant noise in deep space telemetry, but internally, researchers knew they were watching something different. The data showed persistence, the unmistakable sign of a system continuing to operate without a driver. In one late-night teleconference, an engineer from the Goldstone complex summarized the dilemma plainly. If this is feedback, it should decay. It's not decaying. By the new year, the pulses were still coming. Faint, but perfectly timed every 14 hours, 2 minutes, 17 seconds, as steady as a heartbeat. Mars, once silent, was now emitting its own rhythm, echoing an object that had long since vanished into the darkness beyond Jupiter. Some saw it as simple physics, a long-lived magnetic oscillation. Others whispered that the planet had learned the pattern, that once resonated, it now continued to hum on its own, like a bell that refused to stop ringing. Whatever the explanation, the message was clear. 3 I-Atlas had come and gone, but something on Mars had remembered it. And in that quiet re-emergence, the red planet was no longer just a witness. It had become the instrument. By January 2026, the signals had faded into the background. Not gone, but quieter, woven into the natural hum of the Martian sky. Telemetry returned to normal. ESA resumed routine updates. The headlines stopped. The world moved on. But for the scientists who had watched the data unfold in real time, the silence didn't bring relief. It brought questions, and one question in particular that none of them could shake. The question was simple enough. What did Mars just do? Because for all the data, all the magnetic readings and hydrogen veils and synchronized rhythms, the planet's behavior didn't fit any model of passive reaction. It hadn't merely absorbed energy from 3I Atlas. It had reflected it. For the first time in recorded observation, Mars had acted like a responsive system, one capable of holding, releasing, and repeating an external signal. Something in its atmosphere, or its crust, or its core, had changed. The first theory came from geophysicists at JPL. They proposed that 3I Atlas's electromagnetic field had temporarily induced charge domains deep within the planet's mantle, essentially magnetizing parts of Mars's iron-rich rock. When the external field vanished, those domains slowly relaxed, releasing their stored energy as low-frequency oscillations. The process would look like intelligence, but was really just physics. The geological equivalent of a struck bell continuing to ring. To the data-driven mind, this was comforting. Simple cause and effect, but others weren't convinced. They pointed out that the signals recorded after Atlas's departure weren't decaying exponentially, as any natural resonance should. They were self-correcting. When one cycle weakened, the next grew stronger, keeping the amplitude consistent across weeks. That suggested feedback, not a single tone fading out, but a dynamic system adjusting to maintain rhythm, as if something had learned the pattern and refused to let it die. In early January, the Goldstone Deep Space Network captured an unexpected transmission from Mars during a standard comms calibration. It wasn't data from any spacecraft, just a faint modulation buried in static. When engineers isolated it, they found the same 14-hour frequency repeating in perfect sync with Mars's rotation. It wasn't a message in any conventional sense, but it was structured. Goldstone's report concluded cautiously. The signature exhibits artificial coherence without artificial origin. In plainer terms, it looked organized, but there was nothing there to organize it. Across agencies, small working groups began to meet privately. They didn't talk about aliens or intent. They talked about thresholds. Could a planet become a resonator strong enough to sustain electromagnetic patterns indefinitely? Could an interstellar object like 3I Atlas carry frequencies so powerful they leave imprints in planetary systems? And if so, how many other worlds had already been touched without anyone noticing? The philosophical implications came later, whispered in late-night emails and off-the-record calls. If 3I Atlas had the ability to imprint Mars, then every planet it passed might now carry some trace of it. A distributed memory written not in DNA or code, but in magnetism itself. Perhaps the universe didn't need biology to remember. Perhaps it used physics. By mid-January, a small consensus began forming not about what had happened, but about what to call it. They named it the coupling hypothesis, the idea that under the right conditions, the magnetic field of a planet can synchronize with the plasma frequency of a passing object, creating a temporary feedback loop. The result isn't communication as humans understand it, but resonance, a kind of energetic acknowledgement between bodies, like a key fitting briefly into a lock. Still, even that explanation left one final, unavoidable question, the one that echoed through every lab and mission room. Why Mars? Why not Earth, or Venus, or Jupiter? Why did the resonance focus on a dead, dry world with no life, no oceans, no shield? What made that one silent planet capable of responding when all others remained still? No one could answer. Perhaps its thin atmosphere made it more sensitive. Perhaps its crustal magnetism aligned just right. Or perhaps, as one senior researcher wrote anonymously in a private note later found in ESA archives, maybe it wasn't about the planet. Maybe it was about the place, the one world that still listens. That sentence never made it into any publication, but it lingered in conversation like a ghost. Because deep down, none of them were sure whether Mars had simply echoed the comet's song or whether it had understood it. By the time the signals truly faded, the data archive spanned terabytes. The theories filled hundreds of pages. And yet only one conclusion felt honest enough to write down. Something happened between Mars and 3I Atlas. We don't know what it was, but whatever it was, it did not end when the comet left. And so the story of 3I Atlas closes not with certainty, but with the question that always follows discovery. Not what did we find, but what has already found us.